I think the vibrators failed. It's got the right voltages going to it, but it's not operating. Okay, so I think we can either try to see if we can, let me take a look at it and we'll see what we want to do. Hey guys, before we get started, I want to make a couple of comments about this unit. You know, a lot of us that watch, people who watch my channel watch the same kind of things I do, and they're, about old, tube radios, tube televisions, and you're accustomed to seeing instances of hundreds of volts, if not thousands of volts, particularly on televisions. But we can become complacent in terms of thinking that that is usually within the cabinet or within the case. In this case, with this unit, there is actually a wire that hangs outside of the cabinet of this, that if you were to put power to this unit, it'll generate 1,000 volts out at the end of a wire that's just hanging out there. You might not suspect something like that was possible, so I want to give you a heads up on that. So I would encourage you to not try to do anything I'm doing here. If you have one of these, be aware. You may want to take this to a serviceman. If you're not one yourself who's familiar with this kind of equipment and this kind of voltages, and make this safe for your purposes. Or not use it at all if you like, but I would encourage you, just take a look at my video. Don't attempt to do anything I'm doing here. Just enjoy looking at some history, and thanks. Okay, so I'm doing some troubleshooting on this vibrator. All right, you can see I've cleaned up those pins pretty well on here. I also cleaned up the sockets pretty well. So what I want to do is let's just take a look at some measurements on this. So here's the diagram of the vibrator right here, and that should correspond with the way these are right here. You'll notice that the two large pins are on the left, the two small pins on the right. Okay, let me kind of talk through a little bit more in detail about how the vibrator works, and then we'll look at how this tests. Okay, so as you saw before, we got the power comes in and goes to either side of this coil. This is a center tap. It feeds both sides of this. So in the position that it is right now at rest, that's the way it is when it doesn't have anything happening. And so you see there's a read that's over in the down position. That's this line right here, and it's contacting that lower arrow, which is touching this lower pin here, and that connects to the lower half of this winding. The upper half of the winding comes in, and it's actually tied. I'm trying not to be shaking. It's tied not only to that pin, it's also tied to two things. One of them is it's tied to a contact that is not touching the reed normally. Okay, and it is also, though, connected to the top of a coil. And here's the coil that comes down, and then it comes around this way. It jumps over and then goes to this top pin, and that goes to ground. So what happens is when you energize this with DC, 4 volts DC, this comes up, energizes that port right there. The coil then gets 4 volts across it, that then goes to ground, and that's what causes this to develop a magnetic field that then pulls this reed up. And as it does, it makes contact. When it makes contact on this upper part here, it does two things. But one of the things it does is it shorts out the coil, so that now the current coming in, instead of going through the coil to get to ground, goes through that contact to this reed and goes to ground, which has essentially no impedance, okay, instead of whatever the impedance of the coil is. And though that causes the coil to drop out, and that causes this reed to flip back down to the bottom position. Once it breaks loose of here, then this coil can generate a field again and comes back up. This should drop down far enough to where it touches this set of points, and then when it goes up, it touches the top set of points. And as it sits there and vibrates back and forth very fast, what it does is it ties first this lower part of the coil to ground and gets flow going from the center tap to this direction. And then when this side touches, then this goes to ground, and then this pulls more current this way, and that causes the alternating current going back and forth, right? So what I'm doing is I'm checking to see whether this vibrator is measuring like we're supposed to see. So the first thing I want to do is I want to check to see if I have any continuity between this post here and that post, showing that this read is touching that set of points. Okay, so I want to check for continuity between here and there. So I have this set on ohms, and I'm going to check from here to here, and we get nothing. And just to double check, my leads are okay. I'm getting nothing there. I can feel this rebounding inside as I hit it. It doesn't seem to be affecting anything. So it's not touching, or it's not making contact through there. Okay, now let's check. So that just shows that we don't have continuity from that pin to that pin through that contact touching this reed up to here. Alright, so now let's go to the other small connection. Okay, looky here, we got about 16 ohms. So that means I have 16 ohms from this point to that point, which means that this reed is not touching that point. It's going through this coil. It sees that coil, and that coil impedance must be about 16 ohms. Okay, so let's verify if that's what we're seeing. So that's between these top two locations here. Let's see what I'm doing right. I'll take those off. Let's get our old friend the component tester out here. Set it down here. And we're going to connect it between that top post and here. So once again, we're checking between here and here. We're looking to see if we see a coil or just some kind of resistance. And look at there. Can you see it? It sees an inductor, 22 ohms, 22 microhenries. That's the coil. That's the coil that's supposed to be operating. And just to see if this also sees nothing going the other way, put that back. Nope, put it on this side here. And this is where we had nothing before. Yeah, nothing. Okay, so what it looks like is it looks like that even though this is getting energized, this reed isn't moving back and forth. Well, let me put it this way. It's not contacting that location, and it's also not contacting the lower position. So this reed is somewhere in the middle, or these points are so heavily oxidized they're not allowing anything to go through them. I could try putting a big jolt of power through it, but I'm not going to do that. But that's what's happening. So this coil is okay, and we're getting that continuity here, but we're getting nothing from here to anywhere. So if we want to try to fix this, and that's the problem is inside of here. It's not the contacts. It's inside of here. Not the pin contacts I'm talking about. It's these contacts in here. Particularly looks like that's not touching here, and it's not pulling off that way either. So there's something wrong with these two contacts. Okay, I'm going to hook up the vibrator outside of the unit with the leads going in there, and I'm going to try giving this a few bumps to see if I can get it loose to where those contacts will finally start making contact and going, because otherwise the only other alternative we have is trying to find a replacement or cracking this thing open, and we may end up getting to that point. But let's just see if we can maybe encourage it to get going, and then maybe it'll self-clean itself. I don't know. So let's just see. Turn this down. Here we go with power. I can feel it shaking in there as I'm striking it, because there's some sound insulation stuff in there too. I think I felt it vibrate just a minute ago. Yeah, I'm getting it to buzz by shocking it with voltage. I can feel it starting to buzz. That's interesting. Put that here. I can feel it trying to go. I think the coil is moving the reed now, but the contacts aren't making contact yet to keep it running. Maybe I'll just keep beating it. Maybe it'll start going, huh? I wish I could tell you, but I can feel it. It's running. It's running. Kind of coming and going. Alright, so what we're going to do is we're going to take this off of here, and I got to get set up for high voltage here. I got to be careful because we do have the potential of high voltage coming out of that thing if it starts to run on me. So let's do this. Let's get this out of the way. Plate of the rectifier. The rectifier is up here, right? Let's see. Yeah, here. So there's the plate of the rectifier is here. So as this thing starts to run, we might want to see some voltage coming up here. Okay, how do I achieve that? By okay. So I'm ready to measure high voltage if it comes up, but now I'm back to where the vibrator's not working. Okay, so now what we're set up for is, so I don't have to use the high voltage probe. I'm going to be measuring to see if I'm seeing anything develop out of this smaller secondary. And at full voltage it should be 120 volts AC, but I'm just going to see if this meter starts to move as I get this guy starting to operate. That'll give you some indication that the vibrators may be starting to move a little bit. Okay. Alright, so we see I need to be careful that I don't come across that winding right there. I liked this orientation better a minute ago. It's running. Watch this. Watch this. See, it's trying to bounce on up there. If I had an analog meter, you'd see that meter really jumping. So like I said, its target is 150 volts. It'll be higher than that since I don't have a load on it. As you can see, the vibrator's trying to go. It's trying to go and it's trying to make contacts. Come on, baby. Presumably the more I get it going like this, the more it'll knock that oxidation off the points. Okay guys, I'm going to intervene here and try to speed this thing up, because basically I did this for about an hour and kept working on this. I began to realize that that green lead had a bad connection in it. I chucked it out and finally got that green lead replaced with a white one. And then I just worked on this thing. I just kind of kept touching it lightly and touching it lightly. If I clipped the ground on hard, it would just stop running. And then sometimes it would just stop running anyway, and I would just have to go back and turn it around on its side, tap it, and then very lightly touch it and just kind of brush the ground lead against the chassis to complete the circuit, and I could feel it starting to move. And that's what I had to do for quite some period of time. But if you watch the voltage on the gray meter, you can see that it just wouldn't keep going and generate that 120, 130 volts or whatever that would come out of that smaller secondary. So I just kept at it, and kept trying with it. And then I got to thinking, well, what is possibly keeping this thing from running with additional, load on this? I got to wondering about the impedance of the filament in the dim bulb. So I finally went through, and in a minute you'll see I'm going to get up and I'm going to bypass the dim bulb. And then when I hooked it up, that seemed to really make a difference. This thing just took off. It's buzzing pretty good right now. It's continuously running now. It's continuously running right now. Okay, let's watch this. It's continuously running right now. So that's supposed to be running at 4 volts there. Getting 86 volts out of the lower secondary. It should be 120 volts. Yeah, to ground, I'm assuming. I'm going to up this voltage to 6. One and a quarter amps, 91 volts, 6 volts. It's running continuously right now. Boy, this is like one of those videos where a guy's trying to start a car and he just keeps it turning and turning and turning and turning and turning and starts catching. It's running now. I'm going to check to see how much voltage. I've got to be careful of that lead right there. This is what's coming into the amplifier here versus here. I'm probably got some losses in the wires. So let's bring that up to 6. I can feel it vibrating a little more intently. It says, yeah, man. Okay, we're at 6 volts. This lower secondary right here, okay, is supposed to be 120 volts AC. We're at 93. It's going up. Look at her go. Should I risk trying to hook up the high voltage while I got it running? Yeah. So that's at 93. This lead needs to be connected to there. And now this is going to read 1 volt equals 1,000 volts. So let's see if we're getting anywhere near there here. Okay, this says I'm getting 690 volts out to there. And that's reading directly, 96 volts. Okay, now I could be that when I turn this off and turn it back on again, the vibrator won't run. So why don't we see what happens? I'm going to turn it down. has stopped. Let me turn it back up again. It's running. I've turned it off and turned it back on again, and it restarted. So I think what I'm going to do is shut this down and then take all the leads off and plug this back in, and we'll see how we do. So let me get that set up and I'll bring it back. Okay, I've got the vibrator back in and we're ready to go for power up. I've left the wiring like it is for right now since we don't have these other tubes in here, not conducting yet. So we're just going to see if this thing functions, the vibrator in the circuit, and see how the voltages look. I've gotten rid of the leads that were hooking them all up, and they're pretty lossy at these amps. So anyway, let's bring the voltage up. Let's see. Okay, so what we're looking at here is this is the input voltage in DC coming in. I've got this wired up to look at the AC voltage that is coming in over the small secondary. I'm picking that up from the positive terminal of this electrolytic and from the high side of, I beg your pardon, from the high side of the ballast tube right here. So here we go. The voltage up. That's millivolts. That's volts. I hear it running. You can hear it easier here than when I was holding it. You hear it? Yeah, here's the difference in the losses. See, that's 3.4 volts coming out of here, but it's only 3 volts by the time, 800 milliamps works its way through these lossy leads. Look here. We're at 109 volts already coming out of the secondary and only 3 volts going into the unit. So just that period of time as the thing's sitting there working in my fingers, those contacts when they were coming together probably have a wiping motion and they were cleaning themselves as it was going. Just bringing it up some. Seems to be working okay. I'm watching the amps. I know we haven't changed the wiring here for this 14 amp fuse yet, but I'm not moving much current. And by the way, also in this lead here that comes in, over here I've got a fuse. That's an 8 amp fuse I have in there, and this is 14 amps, so I've got pretty good control here. Okay, we're at the 121 volts already that we're supposed to get coming off of here, but we have no load on it, so it makes sense that it'd be higher. This is exciting. Can't wait to check the high secondary. Okay, I'm going to just hold it there. We're at 150 volts there. I'm only at, I'm going to hold it down below 4.5 volts. Since I'm not drawing any current, that full voltage is getting pretty much into here. I don't know, we're at 1.25 amps. All right, so we know the small secondary is working great. Here, let's see what we're getting out of this guy right here. Okay, I'm going to have to switch probes because that can go pretty high. All right, so let me just, okay. So where I'm connected this up, just to refresh, is I'm going to check the voltage across this side here. I'm picking that up from the high side of this filter capacitor right here as it's going into this rheostat, and then the other side of it I'm picking up at the empty socket for the plate for the rectifier, and that's what I'm going to touch now. There's a cord coming out of the transformer. I can see it clearly. Okay, so here we go. Once again, if this says 1 volt, that's 1,000 volts in reality. So let's see what we get. Well, there's 1,145 volts. We're supposed to be getting 1,150. So we definitely not holding it very well on there. We'll go ahead and go up a little bit. So there's 1,200 volts. And then we can bring that on up. Can you see that okay? Let's see if you can see that. See that better? Oops, what did I do? Hit hold. Reset. Okay. So there, that's 1,230 volts. So, yep, the higher voltage secondary looks great. Like I say, with full operation load on it, it should be 1,150 volts, and we've got 1,230 with no load on it. I would say we've got ourselves a working power supply. That's great. Okay, we got the vibrator to work. We're getting voltage through the transformer. This thing, I'm gonna turn this down. This thing is ready to go. So, what do you want to do now? The question is do we want to put these tubes in without the load on it? It probably wouldn't hurt anything, but I'm thinking, why don't we go ahead and put the load on so it would work as a unit. What I'm going to do is I'm going to go in and just check a few resistors to make sure they look okay. I know that these capacitors will probably be leaky, but I'm going to keep the voltage down low. We're just going to see if it comes up, monitoring the current and so forth, and we'll just see how it behaves. If it acts weird, then maybe we'll go in and do something different. But let's see how it works. If it works fine right now, then I'll know it basically works. And then if I do any work on it later and then something doesn't work, I'll know it was something I did versus maybe it was never working for some reason else. So let me do that. I think what I'm going to do is go ahead and make the, let's see, should I go ahead and make the change with the, no, I've got 8 ohms on here. We'll see how it does. And I'll try to keep the current down to the overall system. And we'll just see if everything gets its conduction to itself, and we'll see how it behaves. We'll go step by step. Cool. That's really amazing if you think about it. You put in 4 volts in this thing starts buzzing, and you get 1,000 volts out. That's amazing. Yeah, so I thought it'd be a good idea to go through at this point and just check out the resistors that are in here and make sure they're in decent shape. And you know, they get you typical, you know, that's within tolerance. This one shows where it's currently set. Over here, this one's 30% high. This one's 20% high. This is probably within tolerance. Those are, they don't have any bands on them, so they're 20% resistors. This one might be a little high. We'll just see how it behaves. But one of the things I've noticed as I went through here is, and I haven't finished going through them yet, but this guy right here, this 330 is measuring essentially 0, like it's a short. So I went through and checked everything, and it all looks good. I thought I was getting 0 here on this 330 that goes across the points of this, but then I realized, well, that's in the energized position for the coil, which it doesn't have right now, so that should be contacting. So if I just go like this, there it is. So that resistor is not a short. It's fine. Okay, so having found that that's correct, that's okay. The rest of these are okay. I think what I want to do now is we'll check these out. So we get to open this guy up. That'll be interesting. Okay, so we've got the eye tube out. We're going to open this thing up and check out its circuitry inside, make sure it's looking all right. So let's go in there. It's interesting. This is, you may have noticed the other side of this has a socket that looks the same as that. It's missing a coupling that needs to go in there, so we'll deal with that later. There's got just 2 leads going in. The black lead I've identified comes from here, from that adjustment, and then the white lead is what comes in and goes down here to coming into the grid of the amplifier. Okay, let's open this thing up. First time for me anyway. Same length. Okay. All right, very nice. Looks like it's die cast zinc. There's the lens. It's just loose. Here's sensitivity adjustment. That's this guy right here. And there is a photomultiplier tube. And there's a lens. I'll get you in here you can see this better. Warning, high voltage, right? You got an amber lens. I believe that amber lens is for the purposes of when it's foggy or snowy. It helps with that. I think later versions of this put the amber lens here in the front. Now in there is the photomultiplier tube. And I'll describe that in a minute, but I am not planning on disturbing that if I can avoid it, because it may be aligned somehow, the way it's held in this bracket and so forth. So, and since I don't have a way to realign it, I'm just going to leave it like it is. And there's the bottom of the tube. It's got an orientation key like an octal would have, but a whole lot more pins. Okay, well I think I can check the resistor network by going here and see what we got, so I don't have to take anything apart. Okay, let me take a close look at this, figure out what I'm going to do, and then I'll start looking into how I'm going to measure this and how I'm going to support it. Okay. Pretty cool, huh? Okay, so I went in here and tried to do some measurements of some of the resistors in this printed. It's a printed network in there. I don't know if you can see them in there. You can see, I'll give you some light. But if you look inside of there, there's like a printed circuit board that's got the printed resistors on them. And so anyway, I tried measuring them, but there is a double path to ground on this. You got a ground over here, but then also this leg here of the sensitivity control goes through 1 meg to ground. And so basically to get the accurate measurements, you need to lift the leg of the center off. And I decided, before I start doing any of that, I thought I'd just check to see if I saw any shorts or anything like that. I did not see anything like that. Some of the measurements I got didn't look quite right, but it gives you a big range in the manual what to expect. So basically, I think what I'm going to do is just say I've gone in and done a visual check on this, and it looks okay. So I think what I'm going to do now is consider going ahead and hooking these two up. I think what I'm going to do is configure this in a way that it's in the manual about how to test this unit outside of the car, so I'll know what sort of things need to be connected and not and so forth. And I guess I'll get that set up and we'll see how we do. Before I button this back up, I thought I'd take the opportunity to talk about the photomultiplier tube, because once I cover this up I probably won't open it up again unless there's a problem with it. So this thing has 11 pins on it. Okay. And what you're seeing on here is these individual elements are called dinodes. And so you've got a plate and you've got a cathode and you have these dinodes. As you can see, there's a resistor network that's set up to provide a different potential between each of these that increases or decreases which way you go and which way you look at it. So what you have is you have a window where there's a special screen there. It's called a, what is it called? A photocathode. It's right here in the front. Photon light will come in and it'll strike that material in there, and there's some focusing that I think is possible. But basically it goes in there and it strikes one of the diodes. Well, the light beam comes in, because of the photoelectric effect, it kicks off an electron or series of electrons for the photons that hit. Then those electrons fly off and they go to a diode. Okay, now the diodes are actually set up like there's like one like here, 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 stepping through this. Okay, and so the first electron, if you and these things are set up with a potential between them, where they're just right ready to conduct. They're ready to conduct. They just need a little bit to tip them over to where they'll conduct some. So what happens is that electron that gets knocked off from the photon comes off and strikes this, which then gives this one enough energy to where this will now conduct between these. And then once it does, there's some scatter that comes off here that's captured by the next one, and this one conducts. And it does even a higher amount. And what it does is it goes through all these diodes. It becomes more and more. It's kind of a cascade effect until you get enough electrons flowing to get to the plate. Okay? And then that is what gives you the signal that comes out that goes to the amplifier tube. So that in a nutshell is kind of how a photomultiplier works. You can look it up to see something, more detail on that. But that is a type of photomultiplier tube. Like I say, it's got 11 pins. So there you go. Pretty cool. All right, I'm going to close this thing up. Here's our sensitivity control. There's a lens. And it's pretty cool. Okay, so things are about to get interesting. Okay, so there is some troubleshooting instructions in here on how to test this off the car. I don't have the car anyway. So I thought what I would do is use this to go through and verify how things are functioning on here. So what it does is it indicates there's a setup, and I have that, and I'll show it to you in a second. This says disconnect the phototube unit from the amplifier, turn it on, allow it to warm up for a minute, and it says bulb should be off. If it has a mode that's not right, it sends you to a troubleshooting chart. I thought what we would do is start walking our way through these tests and see what we get. Okay, if we get all the way to here and everything seems to be working okay, then it looks like it's good to go. All right, so we're going to be right back here, and it says the phototube unit is disconnected. All right, so here is the connection chart that shows how to set this up. All right, so what we've got is the phototube will be disconnected. So the black and white leads I've got taped down to where they won't be touching anything. These are also out of the way. I've got a test bulb here that goes to the negative. The negative also goes to the chassis of the amplifier. I don't need to connect up to the phototube right now. The positive connects up to the red with neutral tracer, natural tracer, which is also connected with the natural with the red tracer. We talked about that a little while ago. All right, so let's go through this and see how we've got this set up. All right, so we've got is the power from the power supply is coming in. I may not have enough power for this. I have another larger power supply that I could use. It's not regulated, and it may work fine. I just have to be careful with it. I also have an all points bulletin out with a bunch of people trying to find me a 6-volt battery. But anyway, and there is one of them right there. No luck. Everybody moved their stuff over to 6 volts. Even my friend that's got a 47 Jeep did the same thing. He's on the 12. Okay, so the power comes in from the power supply through leads here. The negative I have connected to this bit of ground braid that I'm using for connecting up several grounds. It's on that point right there. The positive comes in here. I'm using a gator clip just to hold it against this spade lug. The other end of it I've got clamped out of the way. Here's where I'm measuring the input voltage, right as if this was connected to the battery, if you will. So I want to see what that is when that is 6 volts. The negative for that measurement will be on the chassis. There's a braid there that goes right to chassis. The negative connected to the chassis I have right down here on the chassis. I've done an ohm check that has continuity through there. Okay, so that's connected here and here. Right in here I have the leads that will go to various other places I know will be hot. This are the 2 leads that go to the, I won't ever do this again. These are the 2 leads that go to the photo unit. This one's the black lead and the white lead. This will develop about 1,000 volts between these two. And then this is that test bulb that we were talking about. Okay, and that thing is connected between the natural with the black trace and ground. And the natural with the black trace goes to the relay. All right, and we'll get into this later about what the bulb position means. But basically, if it's lighted, let me see if I got this right. Basically, I believe when the bulb is lit, it's supposed to be that it's in the low beam position. But we'll work through this and we'll see. Okay, so we got high voltages going on through here from now on. We got to be careful, especially right here and here. All right, and the photo unit is here. It's out of the way. It's not connected right now. And let's just see if we can get enough power to operate this and see what we get. No, we know we will. We just want to see if the bulb comes on. That's what we want to do. That's the first test, is turn this on. We'll take this to 6 volts. Okay, get this to where you can see it. Okay, all right. By the way, I had this box sitting here, and I read somewhere that you're supposed to be able to read information on here that shows what the voltages were when this is originally set up. And I thought, where does it say that? Oh, what we have here. So this tag shows a schematic. Sorry, the way the lighting is right now, you can't really see it. I'll put a picture of it up on the screen. So it shows that if you do a disconnect here and put in a 2 megohm resistor, what kind of measurement you should get at that point, assuming that the voltage at the point coming out over here is what it says here. That says 3.9 volts and that says 900 volts. Also, what's interesting is if you look right here in the upper corner, you'll see the date of manufacture of the amplifier. Sorry about the way the lights are. It says November 11th, 1952. So now we know when this was built. All right. Hey guys, I want to make a comment about this schematic while we've got it up on the screen. What's different about this schematic is that it shows the elements of the tube schematically, unlike the representation in the schematic we've been looking at that just identified what the pins were. But this, you can see what the representation of the structure is within the tubes. I want to make a comment about the amplifier tube first. Here you can see it's a dual triode, and you can see by the way the filament is wired that it gets 6 volts going both to the left and to the right, so they're in parallel. So this would be a 12 series bulb. I believe it is a 12AU7. I've looked in the tube manual, so I think that could be a 12AU7. I don't know that for sure, but if any of you guys are looking for how to replace that tube, you might check that out on your own, see if you think so. I do think I remember seeing in a forum somewhere somebody writing that theirs actually had printed on it 12AU7. Now the rectifier tube up above, I haven't yet been able to identify what that is yet, but you can see it's got a direct heated cathode there at pin 3. It's got a heater cathode, and you get the plate at pin 1. It's a miniature tube, a 7-pin miniature. I can't tell you exactly which one that is. I don't know if it's actually a full wave that only has half wave hooked up or not. The other comment I want to make real quickly is if you'll notice that the heater cathode is tied to ground, and the plate then goes through the coil like you normally would have to a center tap on a full wave, and where that other lead would come off at the top where I've been tying the negative lead of my high voltage probe, that is actually B minus. Okay, so when I've been hooking my probe up, I've been hooking my negative to the B minus and testing things, and I've been getting positive voltages because of that. But that's actually a B minus line, so effectively compared to ground, that top lead is actually negative 1000 volts. So I'm just going to set that back down here. Another thing I've got is that I have the dim bulb, which is back here, in the circuit again, just for when I turn it on initially, just make sure I don't have any problems. Even when I hook up the photomultiplier, I'll make sure that's hooked up into the system just to make sure there's no undetected shorts yet. At this point, I don't expect a problem. All right, let's start this up. I'm going to move this light bulb off this background so maybe it'll be easier to see. Okay, so we go to 6 volts. Measuring it here. Half a volt, 1 volt. Vibrator just started. 2 volts, moving 600 milliamps. Oh, you know what? I need to put the tubes in. I'll be back. Okay, I've got the tubes in. I'm ready to go. There's the rectifier tubes in, the amplifier tubes down here. We're all set to run. I've got my high voltage probe set up in case I want to do a test during this. Here's the light bulb we're going to watch. And once again, what we want to do is turn this on, let it warm up for about a minute, and we want to see that this bulb is off. Okay. Looks like it's already working, right? Okay, let's bring the power up, voltage up. I may not have enough power out of this power supply. We'll just see. There's the vibrator running. So this is the first time I've had it running with the tubes in it. So I'm going to, all the tubes in. So let me just look at it. We're at almost 3 volts. Let me see what we're getting at the plate of the rectifier. So let's see, this will go to AC. Can you see it? No, you can't. Can you see it? No, not come across those leads. Okay, let's see what we get, if anything here. Okay, we're at 600 volts at the plate of the rectifier. Wonder if anything's coming out of there. And we'll find out in a bit. Just going to let it run for a second. We've got voltage going to some of these capacitors for the first time. So let me kind of take it easy with it. I had one of the molded type capacitors blow up in my face on a vintage radio a few months ago, and I'm kind of gun shy. At least these aren't molded. But we're going to look for them getting hot. Be able to tell if the wax on them is melting. Okay, there's still no light there, so bring the voltage up some. Hear the vibrator going. It's at 4 volts. Let's see what this says. 930 volts. I'm moving 1 3/4 amps. You know, for them to put a 14 amp fuse in there, you'd think they'd put more amperage in there, right? I guess I'm not running current through the resistors, that are in the photo tube through here. Okay, we'll bring this up a little bit. We're really actually watching here now. Five volts. 1,000 volts. 1,035 volts. 1,040 volts. This is exciting, isn't it? The bulb is off. Yep, no glow on the bulb. Okay, I'm going to bring this up. We'll go 5.5. I'm bringing the voltage up and it's dropping. So I may have a capacitor reforming in there. There is an electrolytic, and something just died. And it started again. That's interesting. Moving 1.6 amps. Power supply is getting warm. 6 volts here. But I've got line losses and the light bulb is in the circuit. I'm at 2 amps. I don't see a glow on the bulb. This bulb here is not glowing. I'm talking about the dim bulb. I don't see anything smoking. Okay. Six volts. Okay. The voltage at the plate of the rectifier again. $1,039 volts. Pretty respectable. Okay, so we're at full power. We're pulling 2.13 amps. I'm just going to let it sit there for a minute or two. Okay, we've been going for some time now, just a few minutes. So it's definitely been on for a minute at least. We've got 6 volts here going into the system as if that was connected to the 6-volt battery here. And we're looking at the light bulb here. I know it's hard for you to see in the light, but I can shield that, and that is not on. The system seems to be humming along fine. I checked the voltage at the rectifier, and that looks pretty good. And the bulb should be off, and the bulb is off. Okay, so that's looking pretty good. I'm thinking about trying to make a measurement of DC coming out of this thing. Why not? Let's do that. Alright, so disconnect this. Bring this over. Hopefully you can see this. Yeah. Okay, put this to DC. I'll put this lead on the black lead. I'm electrically isolated from all this, so doing this is not going to hurt me. Okay, now let's see what we get here. We're getting 1100 volts DC right there. 1100 volts DC. Okay, amplifier unit is working. And we passed the first test because the light bulb is not on. Okay, so the next thing that we do is we did this test. The bulb is off. It is off. So we're going to go to the next one. So with the photo tube disconnected, connect a 2 meg ohm resistor between the black wire from the amplifier to ground. Okay, that black wire is the one we were just messing with. So a 2 meg resistor from there to ground. Alright, so I have a 2 meg resistor made up. What do I do with it? There it is. I have a 2 meg resistor here, meaning 2 1 megs in series. I've tested it, it is 2 megs. Okay, so I'm going to connect it to the black lead from the amplifier, which is this one. Let's see, I want to connect it to ground, and then I want to measure voltage across this, and it should be at least 850 volts DC. Okay, so I need a way to hook that up. I thought I was ready. Okay, so I'll hook up to ground. All right. And I'm hooking up 2 megs between that point and ground. Okay, that's here. Now I need to measure the voltage. So I'll use this again. I'm set up in DC from one side to the other. So here's one side. Okay, and this should be at least 850 volts DC. I'm getting 583. Let me correct this. Okay, I'm getting 580 volts there instead of 850. So now I need to go to chart 2. Yeah, 580. So let me go to troubleshooting chart 2 and I'll bring you back. Okay, so here we go to chart 2. And in this it says, okay, the condition is the voltage across a 2 megohm load resistor connected between the black wire and the amplifier harness and ground is incorrect. Should be within 50 volts of the voltage recorded in the amplifier cover. And we saw that was 900 a minute ago. So that was 850 and we were at 580. So we come here and say, all right, here's the troubleshooting. We measure this. Voltage was not 0, but the voltage was low. Check the adjustment of the high voltage control. We could do that, but I was reading this alone, and I thought I would do this because one of these things here is about a filter capacitor and other things. So I thought what I would do instead is, let me just make a measurement here. Adjustment will not correct voltage reading. Sorry, if adjustment will not correct voltage reading, measure voltage between K and ground. It should be above 900 volts DC. Let me do that first. See, is that anything relevant? And measure between H and E. Okay, they're checking basically the outputs. So what we'll do is we'll measure between K and ground. It should be above 900. K is before, basically is where I've been connecting the lead over here. So between here and ground, right? All right, let's do that. So here's this. So I want to connect this to, I guess I can connect this to ground. There's a ground connection right here. And that lead, which is right here. So this should be about 900 volts. 900, and the polarity is fine. 963 volts. So it actually shows I've got plenty of voltage coming in there, right? I don't know if I trust these leads, guys. It's supposed to be 850. I'm now at 760. Right at 6 volts going in. Okay, if I want to make that adjustment, power control is right here on top. And adjust that to be 850. And it says at least 850. Okay, so I'm at least 850. Okay, we're going to say that's good. We've got that adjusted. So we passed that test. So now we've gone here. We got at least 850. If not, we did the adjustment and got to 850. So now we go back here. We disconnect the 2 megohm resistor from ground and connect it to the white amplifier rod wire. So disconnect the 2 megohm resistor from ground and connect it to the white amplifier wire. Okay, so I disconnect this from ground. The bulb is still off here. You can see that. And what it wants to do now is go to the white wire here and then turn this, it should turn this bulb on. You can see the bulb right here. I hear something clicking. The sensitive relay is clicking. I'm not getting anything at the bulb. But the fact that sensitive relay is clicking is good news. I may just have a bad connection here somewhere. I'll have to look. Bear with me a minute. Let me look, but I am getting the clicking. The sensitive relay is clicking for sure. You hear it? So the relay is going. So we may need to burnish those contacts. I'll look at the troubleshooting, see what it says. Oh, I needed to move this. I got the light to light. Turn it on. There we go. The light is burning. Yeah, I got a problem with my leads. I'm cheap. I should buy some decent leads, guys. I spend too much time screwing around with leads. Okay, so that's definitely glowing. Off, on, off, on. Excellent. 6 volts still. We're pulling 2 1/4 amps. Why did I need 14 amp fuse? Okay, where are we now? So we've gone here, bulb is on, we passed this test. So continue test 2 and connect the red amplifier wire to ground and the bulb should be off. I think it means test 3 because the bulb is on right now. And what we're doing is that red lead goes to the override. And let me see, am I saying that right? Put this back like this was. So if this goes here, it should be turning the light on. It does. It'll just stay on. And then if I touch this, yeah, it's working. So when I do this, it turns the bulb off. All right. So bulb off means high beams. And when you close the override, like you want to flash your lights at somebody, they may turn off your brights. Push this button, it grounds that out, and the light bulb goes out, which means that your high beams come back on. So that works. And this is a typo. So this should say continue test 3, not 2. Okay, so that passed. So now we say connect photo tube unit to the amplifier. Uh-oh, it's getting excited. And now we got to be able to put it in a lighted area or a dark area to see what happens. Okay. I need to connect up the photo tube to these things here. And I need to find something to cover this up, cover the bulb up with, the photo detector, the photomultiplier. So let me go find something that I can enclose that with so I can run this next test. I'll be back in a minute. Okay, let's finish the last test here. So I've got the the photomultiplier tube. This is the item that'd be in the car looking through the dash here. Got some old clothes, a black clothes I'm going to try to put over it to put it in the darkness. And I've got its two leads over here. Now what I understand here to do is I'm going to disconnect the 2 megohm load. And then what I need to do is connect up the black to the black. These are the leads from the unit. I gave you a thing here to notice. And it says in a lighted area the bulb should be on. Looky there. It's the first test we've had of this unit. Okay, we're in a lighted area and the bulb should be on, which means there's headlights coming at us. The bulb on means the low beams are on. So now when I cover this up, we want to see that light go out, which means the high beams will come back up. Let's see how this works. It's still on. So we may have a problem with sensitivity control or something. It's on, and I didn't hear it click anything. So we have the bulb is on, see chart 3. Let me double check my voltage. Okay, it's on. Let's go to chart 3. With photo tube connected to amplifier unit and light entering the photo tube unit, the sensitive relay is closed. Oh, here too. With photo tube unit connected to amplifier and no light entering the photo tube, the sensitive unit is open. We either have a defective photo tube, we'll only know that by substituting a different one, or there's a short of white wire in photo tube. Okay, well that is working there. Question is if I just don't have it dark enough. Okay, well the light is staying on. So that's looking bad for the photo tube. I'm going to go recheck my wiring and recheck the instructions. Okay, well I went through a lot of work to turn off all the lights in here and put this box over this and everything, and it's not operating. I've also doubled up the jumpers here to make sure I had good continuity between these connections, and it's still not functioning like it's supposed to. When it's covered up, that light should go out. And it's still lit, as you can see. So what I'm going to do is shut this thing down and go through and do some checking to make sure I get my wires right, and then backtrack to the troubleshooting again. I don't know, it could be maybe some capacitors have changed since we've been operating it and needs to now be readjusted again. I may go back through the beginning of this from the start, but I won't bore you with that until I find something. Meanwhile, I'm going to shut it down and do some research. Hey guys, I'm going to wrap this episode up here. Things are looking pretty bad for the photomultiplier tube, which I'm pretty sure is hard to find. So, but yeah, I'm not going to give up. There's going to be a part 3. So until then, see you later. Thanks. Bye.